In the last stage, we talked about the principle of information hiding.
which says that we should restrict the access to variables and methods as much as possible.
Yes, in that video, we talked about the visibility of instance variables. Now we need to talk about the same issues, but for variables that are declared within a method. These variables are called local variables. We need to start this discussion with a few definitions. The scope of a variable is the portion of the code that can see and modify its value. So scope is about the structure of your source code. It's something the compiler checks, and problems with scope will be detected when the code is compiled. The lifetime of a variable is the time when the system is running where the variable exists in memory. While the system is running, variables get created and used, and then destroyed. A variable's lifetime is the time between when it gets created and when it gets destroyed. Finally, a block of code is a section of code that is surrounded by curly brackets. For example, the code inside a while loop is in a block of code. Variables can be instance variables, declared outside of any method, and each object gets its own copy, or local variables, declared inside a method, and existence depends on the system running the code containing them.
In other words, instance variables belong to objects, but local variables belong to the code that is running. They aren't attached to an object.
That's a good distinction. There are three types of local variables. Let's look at the definition, scope, and lifetime of each. We've already said you can tell that a variable is an instance variable because it's defined outside of any method. Last stage, we established their scope. If they are marked private,
The principle of information hiding says that they should always be marked private.
true. If they are marked private, only the code in the class that declares them can see them. If they are marked public, the whole system can see them. That's their scope. The lifetime of an instance variable matches the lifetime of the object that contains them. We have watched objects get created, and we've seen that the constructor allocates space for their instance variables. That means that they get created when the object containing them gets created. We haven't really talked about how objects go away. Basically, if an object has no references,
That means no variable is pointing at it.
if an object has no references, then the JVM can choose to destroy the object whenever it wants to. This is called garbage collection, and when an object is garbage collected, that is when it and its instance variables get destroyed. The first type of local variable we're going to talk about are method variables. These are variables that are declared inside a method, but not in the parentheses at the top of a for loop. The scope of these variables is from their declaration to the end of the smallest block containing that declaration.
You totally need an example for that.
I'm on it. Let's look at this method. It doesn't do anything useful. We're just using it to see the scope of the variable x. Here is its declaration, and this is the smallest block that contains that declaration. That means the scope is here.
The scope is from its declaration to the end of the smallest block containing that declaration.
Notice that there can be blocks inside the block containing the declaration, and x is still visible in those blocks. However, the code before its declaration, or after the block containing that declaration, can't see x at all. The lifetime of method variables is closely connected to their scope. They are created when their declaration is executed, or sometimes when they are first used, and they exist until the program exits their scope. So basically, the lifetime of a variable is while the code that is in the variable's scope is executing. Method parameters are variables that are declared in the declaration of the method, in those parentheses right after the method name. For those variables, their scope is the code in that method, and their lifetime is while that method is executing. The last type of local variables is for loop variables. These are the variables that are declared in the parentheses of a for statement. For these variables, their scope is the for loop that declared them, and their lifetime is while that for loop is running. This can cause some subtle bugs. Here's a while loop that isn't doing much. It's printing out a message 3 times. But the point is for us to look at scope. If you assume that this code is inside of some method, x is a method variable, and the scope of the variable x is all of this code. Here is my first attempt at converting that while loop into a for loop. I used the mechanical translation between loops that we learned in stage 2. But this isn't going to compile. Notice that x is now a for loop variable.
We know that because it's declared in the parentheses of a for statement.
That means that its scope ends at the end of the for loop. So the last statement is outside of its scope, and the compiler will give us an error because it can't find a variable named x at that point. In order to fix this, we're going to have to move the declaration of x to expand its scope beyond the for loop. If I move the declaration of x out of the for statement like this, then x is a method variable, and its scope will go to the end of the block containing that declaration. So all of this code will be in x's scope, and the compiler will be happy again. There's one other topic that relates to scope. This is the constructor for the card class from Lab 4.
As a refresher, remember that cards had two instance variables, face value and suit, and that these were initialized to hold the values we passed into the constructor.
Right. So in this constructor, whatever is passed into V got stored into face value, and whatever was passed into S got stored into suit. Sometimes people will write these methods using the same names for the method parameters as for the instance variables. These two constructors do exactly the same thing. In this example, though, there are two variables named face value, and they have overlapping scopes. The instance variable scope is the entire class, while the method parameter scope is just this constructor. When this happens, we have to be careful to make sure that the compiler knows which one we mean. The rule is the variable name alone is the local variable, and we denote the instance variable by preceding the name with this and a period.
Eclipse gives us a clue to what the compiler is doing. Notice that the instance variables are always this pretty blue color, while local variables are this mucky brown-red color.
In this video, we talked about scope,
The portion of the source code that has access to a variable,
and lifetime.
the time while the system is running when the variable exists in memory.
The scope and lifetime of a variable depends on its declaration, and there are 4 possibilities: instance variables, method parameters, and for loop variables. Finally, because a local variable and an instance variable can have the same name, we might have 2 variables with the same name whose scopes overlap. When that happens, we have to be clear about which one the code is referring to, and the keyword this lets us to note that the variable we mean is the instance variable.